We good?
Yes.
Okay, today we're going to do demonstrations on electrostatics. We've already done all of the positives, negatives, and all of that stuff. Today we're actually going to get a chance to actually see it happen. First thing, I've got a hanger here which allows me low friction so that this can turn. We have a piece of some sort of plastic. Now again, is this rubber? No. But what we have, by convention, originally by Benjamin Franklin in the 1800s, we said that anything fur rubbed on plastic or rubber causes the rubber to be negative. Now if it's negative, it means it gained electrons, which would mean this lost electrons. So if this is positive, sorry, if this is negative, this must be positive. Now this is called conservation of charge. What do I mean by that? In other words, the electrons have to come from someplace. You can't just say, ooh, electrons, they just showed up. They have to come from someplace. Okay? Now if you listen very carefully, you can actually hear, can you hear the crackling? Okay, so you guys all know that that's static electricity. Okay, so I'm going to give a good negative charge to this plastic rod, and I'm going to hang it. Then I'm going to take another plastic rod somewhere.
Okay.
Thank you. And I'm going to charge it in the same method. Would we all expect, logic-wise, that if we do the exact same process, we should get the same result? Yes? So if that's negative, then this should be negative also. Do we agree? Yes? So if I make this negative, then we expect... Now why did I push it on both sides? Because you might be thinking it's swinging just already due to me bumping it. But by doing it on opposite sides, I'd say that's pretty convincing that we have two like charges, right? Do they have to be positive or just or do they have to be both negative? They could be positive and we'd get the same result, wouldn't we? Again, if this is negative, then this must be positive. If that's true, then we should get an attraction, because we've pulled electrons off of the rabbit fur. Yes, this was fluffy. She was tasty. No. Lunch in Marie's room, yes. Okay, do we agree with that? Okay, now this form of electrostatic separation of charge is called charging by contact. Let's think about that word. By contact. Basically it means we're touching it. Now you all think that you have to rub something to be to move electrons one way or the other. Or you have to do work on them to force them one direction or the other. But you don't have to just rub them. I could do this and just touch them. But that's just less efficient. Okay? Other forms of charging by contact. If we take we're going to take some tape here. We're going to have long pieces of tape and short pieces of tape. Why? Because we want to know which ones are on top and which ones are on the bottom. So that's our indicator, long and short. Okay? So here's a long piece of tape and a short piece of tape. Now if I separate those two pieces of tape so that we have a top and a bottom piece. Okay? We have the top tape and we have the bottom tape. And watch what happens. They are attracted to one another. So they must be oppositely charged. So let's take these and hang them up here. I'll put the long one over here, which was the bottom tape, and we're going to put the short tape here, which was the top tape. Okay? Now, if I pull the next group, the next two tape off the table, again, we agree that the same process should produce the same charge. Yes? So, the top tape, it's a fun word to say, top tape. So, if this one, what charge is it? I don't know yet. I have no way of telling that yet. But wasn't this the top one also, the short one? Notice they're repelling one another. Can you see it moving there? Okay, let me turn it sideways so it's a little bit more obvious. This out of the way. So, notice we have repulsion because they were both on top, and we have attraction because this was a different process which if these become, let's say, negative, which I don't know yet, then the other one must be positive. So let me go ahead and take this and put it on there, and we'll watch that the electrostatic force is actually stronger than the gravitational force. Gravitational force is actually the weakest force. Okay, this is the bottom tape, which should be repulsive, and attractive. Again, that was charging by what? Contact, because they were physically touching. Well, let's find out if they were positive or negative. We know that this rubber or plastic, when rubbed against fur, becomes negative. So let's take a negative charge and let's find out which one those are by using our indicator. That must be negative and these must be positive. Now, we haven't shown you a positive charge yet. Turns out that a positive charge is a lot harder to make. Now, this is, a piece of my smoking jacket. It's very nice, Okay, this is silk. This is glass. Okay. This actually produces a very weak positive charge. It's actually quite difficult to make a positive charge. I'm working very hard here, and I'm not going to get much. Again, we said that this was negative, if I remember correctly. There we go, positive charge. Okay, again, negatively charged. So now we are sure that we have opposite charges. Agreed? Okay. More charging by contact. Done with this. We have the balloons, if you'll hand me those balloons over there. Now, I may need assistance here, because as you can tell, I'm... Anyway, yes, we call that male pattern sunburn. I'm proud of that. It shows that I'm a man, yes. So who's got a lot of hair?
Right here.
Come here. Nick, come on over, Nick.
This is face hair.
Last period it was Alex Korsinski or whatever the... Yeah. Let's see what we got going here. I'd say we have some electrons being...
Dude Kenton.
Okay. Now, would you agree that again, we have fur and some sort of rubber, latex, whatever, some sort of petroleum-based plastic, yes? Now so we just charge this by contact, right? So again, if you rub this on the hair, and you know what happens when you put it to the wall, right? Uh-oh. Dang it. No. So, come back here, my fur. So, now we have charging by contact, but now let's do something different. We have pieces of paper here. The paper have not been charged. They are neutral at this point. And how is it that a charged object can attract a neutral object? Okay, this is something that we're going to do next, and it's called polarization. Okay, we're going to get to polarization is where you actually take an object and you shift the electrons. Okay, we're going to do this a little bit more later, but let's show this again. If I have a negatively charged object, again, or negatively charged object, and I bring it down, notice what happens at the bottom. Can everybody see down here?
Whoa.
The little leaves are flying out. This is known as an electroscope. Can you see it over there? Okay, let me turn it sideways. Can we see them down at the bottom? Yes? Can everybody see what's going on? Look down here at the bottom and notice the little leaves flying out. Can we see them? Get closer if you need to. There's all this room over here. Now, what's happening here? This is neutral. Well, let me just double check and I'll connect it to something metal and we'll get rid of some electrons. Okay? This is neutral, but it's made out of metal. So as metal, it is a conductor and electrons can flow from one side to the other. With a large negative charge, or any charged object, when I bring this down, the electrons, think about this as like, well, I mean, you all know that electricity can flow on metals, right? So that when I bring this down, the electrons at the top of the electroscope's metal are repelled by this negative charged object, and they flow downward. They get trapped down there on the leaves, and they repel each other, resisting gravity. Do we understand? So, as I'm doing this, notice, this was charged by
Fur.
Which means contact, because they were physically touching, and now I'm charging, this side is now positive, and this side is now, sorry, once again, the negatives flow down, this side is negative, and this side is positive, but only temporarily. When I pull it apart, what's the total charge? Neutral. Right now, though, one side is negative, racing away from the negatives, and the other side is left positive. This is now shifted. This is called polarizing. The community was polarized by the issue. There were people for and people against. Polarizing means that there are sides. Okay? From chemistry, do you remember a molecule that is polarized?
Water.
Water. So let's check that out. If I take a balloon or any large object, Brittany, if you'll turn over this direction.